should be installed at the straight line. If they are not installed properly, then there will be some horizontal alignment deviation, and this is the vertical alignment. They will use some measuring tools to measure the horizontal, to measure the vertical status. And then after the initial horizontal adjustment and vertical adjustment, after all the prefabricated wall elements in the same floor have been completed, then they will do the recheck of each wall panels. The recheck is after all the installation process. So they in this stage they will need to check the panels for the whole floor, like around the 40 or 50 wall panels. So this at current practice, they will using the manual measurement to make the check process, but as they need to make it one by one, so it is time consuming. Like for each panel, they will use like 5 minutes for the horizontal and vertical check. So if they need to check the whole floor, they will take 3 hours to for the check. If the floor has more elements, they will cost more time. So in my research, I intend to use the laser scanning for the installation quality check process to replace the manual measurement process. In previous studies, they mainly use the laser scanning. They also have used the laser scanning for the quality check, but they more focus on the surface defect, flatness, and dimensions. But a few studies have used the laser scanning for the installation quality check. So this research aims to develop a streamlined process for the installation quality check of the prefabricated wall panel, and it can automatically extract the each wall panels from the point cloud, and then correctly identify the prefabricated wall panels that need rectified. Then is the construction, is the case that I used in this research. This is a prefabricated building in Shanghai, China. What I scanned is the top floor of this building. The whole building is using the prefabricated wall panel, and this is the scanned area. I scanned these wall panels for the following check. And as the case is conducted in China, so I used the quality check specifications using the Chinese construction specifications for the quality check. From the table, you can see that the tolerance of the deviations for both the horizontal alignment and the vertical status are 5 millimeters. So we need to make sure that all the deviations of each wall panels and the horizontal alignment should below 5 millimeters. If they below the 5 millimeters, then we can see we can identify this panel is qualified. If it's larger than 5 millimeters, then this panel is not qualified. And I selected 3 laser scanners for the point cloud data collection. These three laser scanners are in different scanner categories. It has handheld laser scanner and the static scanners that use the tripod. And these two, one is the Leica BOK, and the one is the Barrow. They have different speed of scanning, range, and the occurrence errors. So we can get the point cloud data that have different parameters. And then is the data collection process. For this area, we can use scans to get the point cloud data, and use also the handheld laser scan to get the data. After data collection is we need to make the quality check. This is the flow chart of the whole proposed approach. Because we need to do the streamlined quality check first. After we get the data, we need to do some processing. First is the data rejection, because we scanned we have two scans, so we need to do the data rejection. The data rejection can be completed by some commercial software, and it is very easy to be finished. And that is the precise segmentation and object extraction, because we need to extract each wall panels for the following quality check. So because after the data collection, the point cloud data have lots of elements such as the panels, the ground, and some construction materials. So we need to filter these items and then extract only the prefabricated wall panels. So this stage is this process is very important for the following quality check. And after the segmentation, then we'll use the Rendex to fit each cluster. Because the prefabricated wall panels are a plan, we need to make plan fitting of each cluster, and then we need to make classification of the data. This process is to identify the prefabricated wall panels from the ground. After the classification, then only the prefabricated wall panel will be used for the following quality check. First is the horizontal deviation check. After the horizontal deviation check processing, we can identify the unqualified horizontal panels and the qualified panels. Then the unqualified panels will be straight output, and the qualified panels will be used for further vertical deviation check. And then after the vertical deviation check, we can also get the unqualified panels with the vertical deviations. Then after the whole process, we can get the panels with the deviations of horizontal alignment deviation and the vertical deviation. Then is the detailed introduction of the process. The step one is the point cloud segmentation and the panels extraction. Currently, there are many segmentation methods now, such as the model fitting method, region growing cluster-based method, and the global energy optimization method. All these segmentation methods have their advantages and disadvantages. First, we select the region growing method because it is very easily conducted, and the parameters we need to compare is mainly the normal vectors, so it can be very efficient for the segmentation process. But also the region growing has its disadvantages, because the main problem is that the region growing has no universal criteria valid for any case. It means although previous studies have used the region growing for the point cloud segmentation, but because we need to set some parameters first, but they are threshold for the parameters may not be effective for our case. So we need to explore how to select the threshold for the segmentation criteria. There are five main parameters that we need to we need to determine before the segmentation process. First is the K-search. The K-search is for the normal vector estimation for each point. As we know, a point have no normal vector, but they use the K-search to search the neighborhood points around the one point, and this point will be serve as a plan. Then the normal vector of this plan will be used as the normal vector of this point. So this value is used for how many points we need to search for the normal vector estimation for one point. And the number of neighbors. The number of neighbors is for them because we have selected one point. First, we need to the region growing is growing based on one seed point. After the determination of the seed point, then it will search for the neighbor points of this seed point to compare if they belong to the same cluster. Then the smoothness threshold is used for the limit. Is used to limit is used to compare if the two points belong to the same cluster. The comparison process is based on the angles between the normal vectors. Because we have after we have identified the K-search, we can get all the normal vectors of each point, and based on the comparison between the two normal vectors, if the angles between the two normal vectors is less than the smooth threshold, then these 2 points can be seen as in the same cluster. But if their angle difference is larger than the smoothness threshold, then these 2 points will be not regarded as the same cluster. Then the neighbored points will be discussed and not be group and will not be added in the same group. So this value is very important for the segmentation process. And there are two main problems that may be occur in the segmentation process. If we can't set the threshold appropriately, then they will have some over-segmented problem or under-segmented problem. So what we do is to make sure that the segmentation, the result of the segmentation have no over-segmented or under-segmented problems. Currently, this process can only be made on manual experiment and trials. So after several times of experiment, I identified the thresholds for each criteria and get the relatively good segmentation result. This is the segmentation result of the BLK and also for the GeoSLAM. I also can get by setting the suitable threshold. We can also get the relatively good segmentation result, and also for the furrow, we can get the segmentation result. So the as introduced before, these three laser scanners are in different categories and have different specifications. So the data, so their point cloud data are quite different. So the after the segmentation result, we can suggest some appropriate values of the threshold for each point cloud data that can be also adopted in similar quality checkup process. However, it is still hard to make a general quantitative conclusion of the thresholding because also the scanning process will also influence the segmentation parameter setting. Like there will be some erosions of the during the scanning process, as can be seen in this picture. This is one wall panel, but due to the supporting elements of each wall panel, there will be some parts that areas that can't be scanned, so there will be blank. Then during the segmentation process, because they have no point in this part, so the panel will be segmented into 2 clusters. This is also a common problem, but we can't make it as a conclusions in the. We can avoid this problem, and I don't know how to solve this during the segmentation process. Then after the segmentation, we have extract each wall panels from the point cloud data. Then come to the step 2 to make the computation of the quality check. Based on the horizontal deviation computation and the vertical deviation computation process, we can get the horizontal deviations of each wall panel and also the vertical deviations of each panel. I need to mention that the horizontal deviation will not be checked of each wall panel, because the horizontal alignment is mainly based on the panels that should be installed in the same street. If they don't need to install in the same street line, then we don't need to check the horizontal alignment among them. So only these 2 panels that need to be installed in the street line. So we check the horizontal deviation among these 2 wall panels. And then we get the check results. Then the quality check process is streamlined and can be implemented efficiently. The whole process can be finished within 4 minutes. Then the step 3 is the validation with the manual measurement. Now at this stage we can get the quality check result based on using the laser scanning, but we don't know. We need to validate if the check result is the same as the traditional manual measurement. So we need to make some validation. So after data collection on using the laser scanner, I also made a manual measurement of all the scanned panels of the horizontal check and the vertical check. For each panels, I select 5-point position to measure the vertical deviations and also the horizontal deviations. And then the manual measurement result, quality check result, is that these two panels have the horizontal deviations, so they are not qualified. They are not qualified from the horizontal alignment, and also one panel have the vertical deviations. So this is a manual measurement. We need to use the manual measurement compared with the measurement used compared with the result conducted by the laser scanning, and then we can validate if the laser scanning could successfully identify the unqualified wall panels. First is the comparison between the manual measurement with the BLK data. As can be seen that this is the quality check result of the manual measurement, and this is the quality check of the point cloud. Quality check result of the point cloud using the BLK scanner, and this is the result. Compared with the manual measurement, we can identify that all the unqualified elements could be successfully identified by the proposed method. This is unqualified, and by processing the point cloud data, this can be recognized. The unqualified panels can be recognized. And then second, we compare the furrow the result using the furrow dataset with the manual measurement, and the result is also the same as the manual measurement. And the third, we made the comparison between the data collected by Jerusalem and the manual measurement. Using Jerusalem data scanner, the result is not satisfied. Some unqualified panels can be identified, and some qualified panels are wrongly identified as unqualified. So this scanner is not recommended for the further utilization. And then, and in my next step, I will make some detailed comparison about the parameter like the density and some other parts to compare the parameter setting, the relationship between the parameter setting with the quality of the laser scanning data. And I also have some problems that I hope to discuss with you because when I use the traditional region growing, it has some challenges. First is the setting of the threshold. I can only use the experiment. I have made lots of experiments to find the suitable threshold for each data set. So it's very so before implemented in the real construction project, we need to have the threshold first. So this research is to provide some suggested values for the following adoption. I mean, if you use the same type of laser scanner that I have used, like the BLK or furrow, then you can adopt the same thresholds for the segmentation process. And the issue too is that the normal estimation of the region growing is very sensitive to the noise and outlines. And you can see from this picture, this is the normal vector estimation using the region growing. It is very sensitive to the noise. If there are many noise, then the normal estimation could have some problems that not very robust So we need to make some adjustment of the normal vector estimation to make it more robust to the noise. So when using the region growing, these are the two problems that may be addressed in the future. I tried to use because it is very sensitive to the noise. So maybe we need to make the noise removal process first before the segmentation. So I adopted outlier removal process before the segmentation of the raw point cloud data. So I want to discuss with you if you have more better ideas for using the region growing for the segmentation, and also if there is any way to evaluate the segmentation results. I mean, if we can have a more statistic way to evaluate the region growing about the growing process, then we can use the evaluation to adjust the growing method. So I want to know if you have some experience in this part. That's my whole presentation. Thank you.
Thank you very much, Mudan. Very nice and very clear presentation. Actually, your results are quite interesting. You have, if you go on this comparison between measurements and segmentation of the point cloud, 23 or 24, one of these slides. Yeah, 23, for example. So in all these instruments, the first or the second segment, the difference is very big. Do you have explanation why it is so? If you go on the second, after that on 24, the next slide. Yeah, you see the same first segment has a very big difference between what you have obtained with the segmentation and what is measured, and after that 25. Yeah, again, very big difference. Do you have explanation why this element has such a big difference in segmentation and in the measure between segmentation and measurement?
The first two are the horizontal deviation results. It's the for example, this the first two are the relative distance among these two wall panels. So I used the bottom area of this each panel to compute the distance among these two panels. So because in the as we can see that these two panels, there are some rebars and some other elements at the bottom area.
Yeah.
So if we make the line estimation, so there will be more errors that will result the horizontal alignment not very accurate.
Yeah. I see this. But this is, you say about the distance, or this is the horizontal alignment?
Yeah, it's a horizontal alignment. They are not
okay.
Not in the straight line.
Okay. Yeah, this is because of this. Yeah, the first two. And what is the vertical alignment?
Vertical alignment. These are all the vertical alignment.
The rest is vertical alignment.
Yes, I put them together because also they only have two vertical, have two horizontal alignment, and the rest are the vertical line. So I put them in the same figure.
Okay. Yeah, but actually, so none of this instrument is sufficient to detect horizontal alignment because of these obstructions on the ground.
Yes, so if we need to make a more efficient horizontal alignment detection, maybe we need to have a more precise filter algorithm to get only the wall panels and filter the rebars and some other elements at the bottom area.
And what about the SLAM, the last one, the ZEP-REVO?
Because the accuracy of this scanner is very low. So,
but with this scanner, you can go behind the obstacles and you can scan exactly the panels. But apparently they haven't done it, right? Okay. And that's why the error is again very big.
Yeah.
But actually, for the rest, for the vertical, it's, what is the problem with the vertical? That some of them are false positives that are detected as not accurate.
Yes, they're not very accurate. Like this panel, it is not qualified, but it is not qualified. But using the GeoSLAM, then this panel is wrongly identified as qualified. It's this one.
Mm-hmm.
Actually, the difference among the two values are not very big, like 2 or 3 millimeter, but we need to make sure that they can detect the results correctly.
Mudan, you mentioned the density of the point cloud is more is the most for from the GeoSLAM, right?
The density.
The point cloud. The point cloud from the GeoSLAM has the highest density.
No,
Okay.
The Faro has the highest density. What I sent you is about the point spacing. Spacing is the distance between 2 points. Because it's not very dense, so the spacing could be larger than others.
Okay, I'm just trying to explain, or you need to explain why it will identify some panels which are actually installed properly, but then it identified as it needs to be rectified, right?
I think the main problem is that the accuracy of this scanner is not very high. It is centimeter accuracy, but these two scanners have millimeter accuracy.
Okay, so you mean because the accuracy is not good enough?
I guess so.
Yeah. Okay. Is that I remember you have another set of data, right? Which you probably haven't processed yet. Have you?
Yes. I have. I also used the RTC scanner for the processing, and the result is also shows it can identify the result. But I didn't put it in the PowerPoint.
Okay. Yeah.
So it's more similar with the Faro.
Okay. So only the GeoSLAM cannot correctly identify the panels.
Yes.
And that's because of the accuracy of the scan.
Yes, but I need to make a more in-depth investigation of all the point cloud, because I just process each data set, but I haven't make some comparison about the data set. So I need to make further comparison among these data sets.
I'll be interested to see, can you go by yourself and do scanning, or they do the scanning for you on this construction site?
They do the scanning for me, but
do you know how they work with the SLAM? Actually, you can see where they walk because the SLAM gives you the trajectory as well.
Yes, but
do you have the trajectory? Can you see how they walk and how they scan?
Yes, I have the. This is the.
Okay, so they didn't try to avoid all these supporting elements.
Yeah,
if they would have tried to go a little bit closer and do the scanning behind the supporting elements, supporting poles, I guess that you'll get better results, because now you have actually the horizontal evaluation is failing in all scanners. But the advantage of the Prevo of this SLAM scanner is that you can go closer to the construction elements. And then I could expect that is going to be a better result for horizontal alignment.
But the most important thing is the rebus. It is very disconnected with the wall panels. The rebus are connected with the wall panels. They will be scanned together. We can only avoid the supporting elements.
Yes. But you have failure in the horizontal alignment with those scanners, exactly because of this occlusion from the supporting poles. But while the other two scanners, Faro and LBK, they're on a tripod and you cannot go behind the supporting pole.
Yeah.
With Revo, they can go behind. So the Revo should allow to be more flexible in deciding what you want to scan. You're not linked to the tripod and the location of the tripod. And then you might get a better results with the Faro, with the SLAM for the horizontal alignment.
So you mean if I use the GeoSLAM and scan the elements more closely?
Yeah.
And avoid the supporting elements, maybe the result can be more accurate.
Yeah.
Oh.
Yeah, I think Mudan, that's fine. I know you're writing the paper or chapter or something. So just add a discussion section and you can discuss all these possibilities.
Oh yeah, of course.
Yeah. Of course, if you have a chance to have another scan, then but it's probably hard to compare the same floor because the construction has completed.
Yeah,
but
that's
you
also
can always
true.
discuss this in the writing. Yeah, so that's a possibility, and I think that's a very good point because it's not on the tripod, and so you can improve the way to scan it, have more flexibility than the fixed scanners. So in your second paper, you can discuss this.
Right, yeah. But Mudan, you had also some interesting question about the segmentation.
Yes,
and about the noise. Yeah.
Yes, I know that.
The noise.
Yes, I know that many of you are also working on the point cloud segmentation or some other relevant tests. So I want to know some ideas about the segmentation, point cloud segmentation, because like I don't know how to identify the outliers. So although there are some methods to identify, like they can compare the point, they can select a range of points and compare and compute the average distance, and the point more larger than the average distance will be identified as outliers.
Yeah, there are different methods. Mitko, did you use noise removal when you're processing something, especially from the building in fire and rescue?
No, I haven't done any noise removal. This can be challenging a bit how to remove noise. What is noise exactly?
Yeah, one of the methods is exactly what Mudan mentioned, that you compute an average or median value for these horizontal surfaces.
Yes.
And after that, you decide which might be an outlier.
Yeah. For the BLK, I made two segmentation. One is without the outlier removal, and one is just use the data that I have collected, and the result could be different. I mean, the segmentation, the threshold result could be different. But if we have used the outlier removal process, the result could be much stable.
And Nina, did you use noise removal in your point cloud?
No, I haven't used it.
Okay. I remember that. Okay, but probably I remember wrongly.
Mudan? Yeah. I do have a lot of questions and suggestions here. Yeah. Hello, everyone. Yeah, Johnson here.
Hey, Johnson. Welcome.
Yeah, it's a very interesting topic, and also very happy to see you are progressing well while you're in China. So that was a big concern for most of our PhD students stuck in China at the moment. So, and also it's very interesting point to try to compare three scanners, and most importantly, yeah, I think you managed to collect some data from the real construction side. I think that's a big bonus of the research here. Yeah, so I do have quite a few items to discuss with you. To be honest, I think the first one is about the comparison of the scanners, because you mentioned about the tolerance for the the panel installation about 5 millimeter, right? So my first. It's kind of like a direct feeling here is you shouldn't try GeoSLAM at all. It's not accurate enough. So even as a reviewer, I would say that doesn't make any sense to use GeoSLAM, because you mentioned the accuracy is 2 to 3 centimeter, but the tolerance or the target, for the installation is 5 millimeter. That means GeoSLAM is not accurate enough. Even for both Faro and the BLK, it might be a little bit concerned, because 5 millimeter, that's the tolerance for installation. But in terms of measurement, you need to be at normally, I would say 10 times more accurate. Does it make sense? So as a construction, like, the surveyors, normally if the tolerance is 5 millimeter, so it would be better if you can come up with the scanner about 1 millimeter level of accuracy. Otherwise, yeah.
But the accuracy is for the 1 point. If we we have scanned millions of points, then we make some analysis of the points, and then we make some property analysis. Then the result could be the accuracy could be higher. Yeah.
Yeah.
I think my point here is if you look at this table here, the last row, it's about the accuracy. It's like the errors from the scanner. It's plus and minus for those errors, and it includes the measurement error, systematic error of the scanner. So what I'm trying to say, if the construction requirement of installation is 5 millimeter, and then you will, the better that the higher accuracy, the better for measurement. Yeah. So in this case, GeoSLAM, if you mention the accuracy about 2 to 3 centimeter, that means it's not suitable at all for this purpose.
But for the handheld laser scanner, the accuracy are not very high for all the
So
handheld scanner. So you mean the
So what I'm trying to say here is, if I look at your research problem, the research question here, and you definitely need a very accurate scanning technique. So the GeoSLAM, I mean, for even different scanner, there are pros and cons, but just from accuracy point of view, I think GeoSLAM shouldn't be recommended at all for the research.
Yeah, but the answer of Mudan was very correct, that actually you are not measuring one point, you are measuring a set of points, a whole plane. And she said very correctly that when you have more points, you can achieve sub-centimeter accuracy. And eventually this is happening. I'm surprised that with the SLAM she gets more or less the same results.
Yeah.
And this is from, if you look at the trajectory, this is from a quite, large distance already.
Yep. Okay, the other question, actually, Mudan, I think look at Professor Sisi also asked you a few questions about the results, the tables you showed there. I think, all of those three tables. I think especially for the first two items for the horizontal, this check, right? Yeah, I think there must be some errors in the results because that doesn't make any sense. I think my suggestion here is number one, you have 8 points for vertical check, but only 2 points for horizontal check. Why can't you do the same amount of checking? Like, can you do 8 horizontal checks?
No, she has 2 panels.
Wait a moment.
For horizontal check, this is how I understood it.
Yeah, like how many panels did you use for
horizontal checker? 2,
horizontal
right?
check?
Yeah, also 5. This is for the horizontal alignment deviation check, and this is for the vertical deviation check. Because these two should be stored at the same straight line, so I measure the distance from them to the datum line, and then I get the distance horizontal alignment distance of these 2 panels.
But why only 2 if the panels are 5?
Can you do 8 panels?
8 panels?
Yeah, because
you have 5 panels, right?
You have 5 panels, right? Or
they're not supposed to be aligned.
Yeah, because
only 2 are supposed to be aligned.
Only these 2 should be at the installed at the same straight line, and they are not supposed to be straight at the same straight line. So we don't need to check the horizontal distance among them.
So is this like a relative distance between panels, or it's an absolute distance comparing to the floor plan?
No, relative distance.
Okay.
Yeah, because I understand Johnson's question. In that case, we need to check with the original BIM model or something. So in this example, we really just check the 2 panels supposed to be aligned, whether they're aligned. So if they're aligned, but they're not aligned in the right spot, we cannot detect because we didn't compare with the original design, or that's not part of the question.
Yeah, that's a good point. That's a good point. Because when I look at the number there, I thought you only do 2 checks, and then that caused some confusion. Why you have like multiple checks? Basically, you have say 5 panels, and then you can check like a vertical. You can do the vertical checks for 5 times, but then within those 5 panels, only 2 pairs of horizontal checks, right? My last question here, for this building, like a high-rise modular building site, do they have BIM model, or at least do they have like a floor plan CAD drawings?
They also have the CAD drawings.
Is in 2D or 3D?
2D.
2D.
Yes.
Okay. Yeah. So.
And in the real practice, they use the 2D drawings for the whole quality check. So 2D is also enough. for the quality check process.
Okay. So yeah, I know like a BIM is like 3D BIM is not very commonly used for those building construction.
Yes.
And even though they use the BIM for visualization or communication, but in terms of construction quality check or progress monitoring, BIM is not that commonly used, especially in China. So what I'm suggesting here is, you know, purely from research point of view, do you think you can create, you know, based on their CAD model? So you should be able to create a BIM model out of that, and then you might be able to, you know, use the BIM model to filter out the points. For example, those horizontal braces, right? Or a lot of like noisy points. If you have the BIM model, that basically you have the 3D model of the key structural elements, right?
Actually, if we only use the CAD model, because CAD is also CAD. If we use the CAD model, we can also get the.
You just add the height, and then you get 3D model.
Yes.
And then what I'm suggesting here, because the actual construction site with the formwork, with you know, braces and even those like scaffolds, it can be very, very noisy. But you don't care about those noisy points, or even the rebar. You should try to get rid of them. So if you, for example, if you can get the CAD model and then just add the height, so basically you can create a very simple BIM model for that floor, and then, you know, basically, you know, I think that's what one of the approaches we are doing with another PhD student, Mohammed, here. So if you can compare the BIM model with your point clouds, so basically you are able to fill out all of those temporary facilities. So you can just get the point clouds for those the panels only. Yeah, but that's probably just one, you know, like one suggestion here. You can think about that.
Yes, I have read.
But I think she, with the segmentation, she removed the poles. She doesn't have trouble with the poles. She has only trouble with the holes that, or the gaps that are created because of the poles. Right, Mudan? You have, because when she does the segmentation, she, all the poles and other garbage around the construction elements, they're removed. It's removed.
Yeah, the supporting elements are removed.
Yeah, she
Is that
doesn't have
automatically
this.
or manually?
No, not manually.
With
the algorithm.
As a result of the region growing.
Yes.
Okay.
When we input this is the data we input in the algorithm, and this is the output of the segmentation.
Yeah. And actually, the only problem that is there is this disconnected segments. Like on the next slide, Mudan. This is this is one construction element, but there are two segments just because there are holes between the segments and the algorithm cannot go further. But the poles are removed.
Occlusion issues of the laser scanner. So
no, not the laser scanner, the obstruction, the poles that front of the
I mean, it's like occlusion of the line of sight from the mesh.
But this can also be solved if we add the number of neighbors larger, then they may be included as one element. But if we add the numbers of neighbors larger, then some elements may not belong to the same plan and may not belong to the same plan will be grouped. So this is very I don't know how to make the comparison of these two problems.
Okay. So I think overall, I think this is a pretty interesting and very good job for the study. But overall, I think just try to quickly summarize my suggestions here. So for your like internal reference, the comparison of 3 scanners is good. But to me, that wouldn't add too much academic value at all, because eventually you just need to select one accurate scanner to do the job, right?
I also use the for the BLK, I use the two scans, which is in the medium mode and the high mode, and I also use the RTC scanner. This is much higher than the accuracy is much higher than Baro and the BLK, and I also can process the results. Maybe the comparison among these scanners could be more useful.
Okay, yeah, you might be looking at the different scanning parameters or the density of the points. But to my understanding, I think the core contribution lies in your algorithm, like how to automatically process data and get the measurement. That's your key contribution.
Yeah. So I also want to ask how can I add more some technical contribution?
I think to just quickly answer this question. I look at you mentioned about the slides for segmentation, those parameters. You definitely need to play with those parameters. For example, you try to optimize your configuration of segmentation, and then eventually it's working perfectly for this case. And then that's it, you solve the problem. But how to, I think it's all about the know-how, or those are the new findings to the body of the knowledge in this area for sure.
But at the moment, that's exactly her problem. At the moment she adopts these criteria on the basis of manual experiments and manual experiments with a specific data set. So this algorithm for segmentation, it's not something completely new that she developed by herself. So now would be interesting if she can decide something on parameters automatically independent on the data set, because tomorrow some other site is going to be scanned and she has to again play with the parameters and the thresholds to be able to get a good result. So that's why she tests different scanners also to see what is the result from the different scanners and whether she can establish some relation with how to scan to be able to get to some conclusions on the parameters and these thresholds that are there.
I think, okay, go ahead, Sissy. You haven't finished?
No, you wanted to say something. Go ahead.
That's okay. I also just want to summarize. I think that's our purpose, because we look at how to develop a practical approach to solve this problem. So how to find these parameters in practice is one of her tasks. So as Sissy said, we try to identify some parameters. So for next project, we can just use the same setting and can have a streamlined process. We hand over to a site manager or somebody, and they can just do this because we already set parameters. Everything is done, so they can utilize it. So that's a practical value. In some cases, I understand that contribution probably not huge in terms of the technical or but we are trying to develop a practical mechanism. That's one of the purpose. But Mudan is trying to add some more contributions in terms of technologies. So that's why she keeps asking how I could add more contributions.
Yes. Yeah, but this is a good work. She has still quite a lot of time for experiments and developing this process.
I have one question. I would say well done, Mudan. You have good results and you are progressing really well. The main concern that I have is the limited data that you use. You use only data from one site, and you said that you adjusted a bit the thresholds. And the thing is, I had a question in terms of, I mean, can you use the data that I gave you, or like from some environment that are maybe available, maybe not from construction sites, but something that is already built, just to test even in such kind of bit more accurate conditions, more perfect conditions, the results, because I would say the main concern is using only this data set, and you should use more different data set to see the results.
Actually, I used scanned the whole floor, but I just pick up one part. Maybe I can use the because I also have some other parts of the whole floor. I can maybe
but Mitko asked, actually Mitko, she used your data. She developed the whole procedure on the basis of the data that you gave her. And after that, she collect these scans from a construction site. So this is already the second test.
But this is totally fine, just to see the accuracy, how it is changing with more kind of, let's say, accurate data, more perfect data. Maybe it's not from construction side, but the accuracy should be kind of better.
But how can I validate the accuracy? Because in this,
you don't have. How did you validate? You measured like in addition. But still, I think you should get, even if you don't need to validate, you should physically get values that are better. I mean, you know which one should align. Yeah.
You mean the segmentation result? Yeah, the segmentation result, not the quality check result, but also only the segmentation result.
We have also from C5 this area scanned. I'm not sure if I gave you that data, but we have a bit more even accurate. Yes, we didn't measure like as you did in the construction site, but still, I think you should. You should perform more tests, and see how your algorithms work on more different data sets. Maybe just even the same scene that you have, maybe you can take from different angle some parts, just to segment a bit different, in a bit different way, and to have a bit more. Although they are quite similar, but this the same scene you can take only half of it and see the result. Yeah, just you need to have more different data sets to use.
And also, Mudan, just add up to the points mentioned by Mitko. I think for Leica C5, the accuracy is about 1 millimeter. Yeah, you might consider that as well. Yeah, I think just realize another key suggestion here. So, yeah, I think at the moment you are focusing on segmentation, right?
Yeah.
Like the parameters, the accuracy, reliability of segmentation. But I just always try to encourage you to think a little bit out of the box here, because eventually you try to solve this construction problem. That's the point I mentioned earlier. What about the CAD models? What about the BIM models for the construction plan, right? But at the same time, I just realized that whenever you're using the modular construction panels or walls, right, because they are manufactured off the plants, that means the accuracy for those prefabricated panels would be way higher than the on-site construction. So in this case, you should also get the model, 3D models of those panels, prefabricated panels. And then if you use those kind of like a CAD models, doesn't matter you want to use that for training or for just try to assist the segmentation. I think that probably will improve your performance, and even eventually it's all about how reliable your segmentation algorithm would be. For example, if I'm looking at this page, right, for far, and then in this case on the top right hand corner, you showed us the segmented results of each panel, even though some parts are missing, right?
Yeah.
But to me, if you can directly look at the opening within the panel, that's relatively clear. And also, you know the true value of those openings. So eventually, you might be, looking at different ways to segment the panel, depending on the information you're using, depending on the quality of the data you're using. So what I'm suggesting here, yes, you need actually in terms of the inputs, you have point clouds from the laser scanner, right? No matter which laser scanner you're using, but you also have the BIM model for the building, and also you have CAD model for those segmented items. So yeah, if you consider more input or set up some, the rules, I think that should be able to improve the performance or even the reliability of segmentation significantly.
This is more related to the deep learning because we need to do the training.
Doesn't matter. What I'm trying to say here, for example, if I look at the segmented results of the second from last panel, like one portion is missing, right? But you still have the corner of those openings detected. So if you try to detect those key features and then link that to the CAD model of the panel, so I don't need to reconstruct or segment all the panel, but just based on those key features, say the height of the opening, I should be able to easily determine how vertical or horizontal, how accurate they are already. So that means if it's all about robustness of the methods. What I'm suggesting here, you probably need to look beyond the fundamental segmentation methods, and then consider the construction information. That eventually should be could solve the problem better.
Johnson, just a comment. She doesn't reconstruct the panels. Actually, she fits planes in the segments. So she exactly avoids this step, which is quite tedious of reconstruction. She doesn't have feature matching because she doesn't need it. She needs only the planes, which are fit in the segments. And on the basis of the normal of the plane, she computes the horizontal and vertical deviation. This is actually speeds up the procedure of evaluation. She exactly doesn't need to do any kind of feature extraction or 3D reconstruction, which is really kind of very effective approach for quick estimates of the construction work, because the idea of the whole research is to be able to do the scanning and more or less immediately identify which panel is wrong, and after that go and check the panel again. So this is more or less real-time procedure. So she doesn't have a lot of time for many complicated operations.
I'm not sure even that this technique would improve anything, because you need to fit like whole 3D model, 3D object into the scene, and this can be very difficult, and I think maybe the accuracy will decrease actually.
Yeah.
Because you don't have from many sides the object scanned, it is only one side, and it's not that trivial to fit a whole 3D model, like 3D object.
Yeah, that's true. From this point of view, it's also true because you don't have the scan. You have the scan from one side of the panel. You don't have the whole panel, so you with the fitting is you're running the same problem. Actually, what you have to do is to fit one plane of the CAD model with the segment that you know that is segment of the construction panel on the side. So
I think it's not that trivial to improve the accuracy. Probably a bit of use of deep learning and a lot of data if you supply to this deep learning model. Probably this can improve the accuracy to pick up a lot of features. If you do it, if you want to improve it manually, yes, this is I would say a tedious job, and I'm not sure that you can find easily a solution. You need to probably check a lot of things, develop features, see the performance with those features, if they are improving something or not. But you need to find, I mean, probably some place or some area where you think you can improve something and that really can be meaningful and that you can do maybe quickly.
I think Mudan already identify some of these areas, like for example, to try to reduce the noise. This might bring some kind of improvement, and noise reduction is not a heavy operation. So very good.
Yes, exactly. You need to pick up such kind of options and see which one should give a bit better results and go in this direction. The other area is to think something related to deep learning, but you need to have a lot of data, which I think you don't have.
Okay, so Johnson, you said that you have a student that is working also in construction. Is Mohammed?
Yeah, he's also.
Oh, Mohammed.
Yeah,
do you want to tell us something next time about your research?
Yeah, I can ask Mohammed to present. Yeah.
Okay. Oh, okay, he's not here.
It's also just.
Sorry, I'm here.
Oh, okay.
Yeah.
And your research is also on construction sites.
Yeah, we're also related to construction site. Yeah, we are monitoring construction progress, and we're also using the handheld scanner for collecting point clouds and then processing that.
Okay, so probably this is a nice moment also instead of Josephat, because Josephat we are planning for the next time, but he's not that much related to construction site. Probably you can tell us something. What is your approach for monitoring construction sites? Would you like to do it?
I'm a bit busy now. Give me some time later on because we are preparing now in submitting a paper.
Oh, but this is after 2 weeks, not now.
Yeah.
I think
or it's still too close.
2 weeks, yeah. So yeah, I think he's only also working on his. It's like a work on in progress at the moment. Yeah. I think maybe probably the next one would be a little bit, like tight for Mohammed. Maybe we can arrange one after if it's okay with others.
Okay.
Yeah.
Okay. Yeah. So Josephat, how are you?
Fine, thanks. I look at your presentation, Mudan. It's quite interesting.
But now my questions was more about you're ready to present something, what you are working on next time after 2 weeks.
I would like a little bit more than 2 weeks, if you ask me so. But yes.
I think you can present because you're working already. You have quite some ideas.
Yeah, I was telling you, I'm interested in what she mentioned, Mudan, because I'm facing not the same problems, but related, because I'm also working a little bit on segmentation. It's not my focus. I also is a region growing algorithm, but it's a different approach. And of course, I'm not segmenting as a focus, but mostly on reconstructing something.
Okay.
But yes, I think at least I can present what I have so far.
Okay.
Maybe.
So let's see. Let's continue with this discussion about segmentation. We might come with something. You had a question to her, or I interrupted you? Sorry.
Yes, yes, it's more related to the actual object you're measuring, because you say you have issues with the noise. And for the noise, I'm not sure. I assume as a construction site is completely full of rubble and rubbish and everything. So, of course, I'm not sure how rough are the actual surfaces compared to your tolerance or your accuracy of your devices. So, are they really flat? Are they really rough?
Yeah, a little rough. Yeah, not very flat. Not very flat. But I didn't do the flatness check.
Okay. Yeah, because I mean, I'm working on a different type of objects because the objects I like to work with, if you consider them as flat, they're not never flat. They're already built. They're completely off the plane, but somehow I have to extract some flatness. But then in your case, I think they're more flat than rough.
They're not very flat, but I use the Rendeck for the plan fitting, so it will finally the point will be fit with a plan.
Yeah.
We can get the actual surface of the element.
Yeah, because at least for me, it would be nice to see if for the plane you fit, what is the average error for that. So that could give us a clue on.
I think you have it, the mean square from Ranzak. You have it, Mudan. You show it to us. From the accuracy of the plane fitting.
Accuracy of the plan fitting?
Yeah, the Ranzak.
For the accuracy, I first compute the average point spacing, and then I used the twice the average point spacing as the accuracy.
And what is the result from plane fitting? What is the result from Ranzak? You should have it.
Yes. This is for the random fitting, and this is for the BLKM. The accuracy is set at 6 millimeter for the fitting. It's two times than the 2 times of the spacing.
But after that, do you have the estimates? What is the error that you get with the plane fitting, with the selected parameters?
No.
What is the maximum error that you get? The difference between the points and the plane?
Oh, no. I didn't make this computation.
I think I saw it, but it doesn't matter. Okay. Okay, so it's getting already quite late. Do you have some more questions, somebody? Probably not. If there are questions. Okay, so let's finish this session, and please think about these issues that we discussed now. Very good research and very good, well done, Mudan.
Thank you.
Thank you so much. I think Mudan got lots of good suggestions today.
Yeah.
And I think exactly that. Yeah, Mudan got quite a lot of suggestions. Thank you, Johnson, for suggesting so many things for improvements.
Thanks for organizing the workshop, I think.
Yeah, and everybody, and Mitko and Josephat. Yeah, so let's see what is going to be the next. Josephat, right? You are going to say something. Okay, good.
Yeah,
good.
sure.
Yeah. And again, we'll stay on this, let's say, wave with segmentations and plane fittings, and so we can come up with some more ideas. Okay, very good. So, thank you, everybody.
Thank you.
And we'll see each other again after 2 weeks, huh?
Yeah.
And then it will be, yeah, and then it will be 2 hours earlier.
Okay.
Yeah, so it will be a little bit better for you, Josephat. You'll be not that much asleep.
No, I had to take my daughter earlier to bed, so yeah.
Mudan, there's a paper in the chat. You might have a look. I think that might help you. Yeah, from Hashid. Thank you very much for.
Oh, okay. Thank you.
For sending through this. Yeah.
Okay. Thank you very much, Hashid. Okay.
Thank you.
Excellent.
Thank you.
Thank
It was
you.
a good presentation, Mudan. Thank you.
Thank you.
Thank you. Bye.
Bye bye.
you.
Bye,
Bye.
everybody.
Bye.
Bye, everybody. Thank you. Bye.
Thank you. Bye.
Bye.
Bye.